Hello friends. So I created a repo called local elastic stack, which helps me create a repeatable elastic stack for my development environment. It uses the Elastic Cloud for Kubernetes from Elastic, and the samples that are provided, it's based on that. And so I decided to create a slightly longer video to explain what this repo does, and also to show you some example applications that I test this local Elastic Stack with. So here is the repo that I created, and here it's more or less the setup that it will create. So let's walk through that. So essentially, Elastic Cloud for Kubernetes creates some custom resource definitions and operators, and they basically manage your Elastic Stack. So first, we're going to apply the CRDs and operators, and then based on that, we will create some sort of Elastic components, and then we can start using them. And so this is in this order we will do that. So let's start with that. So the first thing we should see is that I have a Docker for desktop with Kubernetes on this Windows machine. So I can see if I have any pods. I don't have any pods. I want to see how many namespaces are there. There's only the default namespaces. So let's start by creating or applying the custom resource definitions. So I copy this and create this, and I copy the and so let's just check how many namespaces do we have. So now we have one more namespace, the Elastic Systems namespace as well. So this is good. So the next step is I find it easy to create an Nginx ingress, so I can easily access this application and other application, the Elastic applications as well. So I copy this and we apply this in here as well. So this will take some time, not that long. So kubectl get pods. We don't have any pod still, but -n ingress nginx. So we have actually a pod that started. That's an ingress pod. And if we see get ns, we actually, of course, we have the nginx namespace as well. So now we are ready to apply our all-in-one file. We will walk through the code for all-in-one file and see what it does. So once we do that, it takes some time to download the containers and images, and download the images and then creates the containers and start the pods. So get pods -n dev oops. I call it dev oops because it was a very funny talk that I attended in DevOps in 2019 in Antwerp. I encourage you to check that talk out. It's thought-provoking and interesting. But right now we see that FileBeat is restarting, and then it takes other pods are starting, and they're starting properly. I started this with the kubectl get pods for DevOps namespace with minus watch. So it will take some time. So I will see if I'll wait for it and speed up the video. So it seems like something's happening. Let's just check the overall pods. Do we have 4 of them? Yes, we have 4 of them. It took 2 minutes to get everything started. So now the thing that we need to do is to just go and see if we can go to Kibana here. So interestingly, this doesn't work. I may need to restart the application. All right, so I am restarting my machine and Kubernetes again. Sometimes I have some networking issues because of some other VPN settings, but let's see if this works out this time. Okay, so at least it's better than nothing. Like, you know, we are still getting, at least we're getting the Nginx ingress, and the service is not available. We can actually see, is it coming up or not? It seems like it just started again. So if we try again, so now we have Elastic Stack up and accessible. So username and password is Elastic. We will look into that as well. And it's the latest version. And then it also has some pro features that you can use on a trial basis. So let's walk through some of the code for this local Elastic Stack. So the first thing we do is just create a secret, and that secret is just to create an enterprise trial license, and it's an accepted trial license, and it's valid for 30 days or so. And this is done in the Elastic Stack namespace that we talked about, where the operators are installed. And the next step is to create namespace where we are going to do things. It's good to specify, or it's good to separate the namespace where your Elastic operators are and where your actual stack is, because they're two different things. One is operating the other. So I choose to call it DevOps, and then I create a simple Elastic password that is used by the Elasticsearch. So we create Elasticsearch, and we call it name ESDev, Elasticsearch development, in the namespace DevOps. We are going to use 7.17, and then we specify what type of in the specs, like what's the container, and I choose to give it like some not so much memory. I tried with lower memory, but I was having some issues on my cluster. You can try something less, but I think it's if you're running Elasticsearch, Kibana, APM, and your own apps on a Kubernetes cluster on your laptop, you probably need some good amount of RAM. So that's why I think it's good to have 32 gigabytes of RAM for a laptop. Maybe it's not so much needed for Linux laptops, but for Windows or Mac, if you can run Kubernetes, I think it's good to have that much RAM. and then you can allocate that. And then of course that's one thing, but this is also for the container, like the how much memory and CPU, etc. And then this is I'm not entirely sure what this is actually. I copied it from the Elastic samples or so. But then this is interesting, but the next step is to create Kibana. Also the same version, and count is 1. Let's see, what was the count here? Count was 1. So we are doing everything as 1. And over here, there are some interesting things. Like so I want to have the base path for Kibana as /Kibana. And to make it easier for things like, since I know where I'm going to be accessing it from, I already put this particular public base URL. So it's easy to access. So you can see how I didn't need to do any HTTPS and, no warning or anything. I just went into this particular application. And for that, we also said like disable TLS. And again, we see the specs like for Kibana. But at least I have like more things, like for example readiness probes and etc. Maybe it might be good to have something here as well. And then Kibana's default port is 5601. And so we are going to be when we are creating ingresses, that's something to watch out for, like this path and this ingress. More like options, etc. So don't use too much memory, but I think 2 gigabytes probably enough. And over here it's referring to Elasticsearch, which is going to use, that's the ESDev. So that's the ESDev that we created before. Then we go to the APM. So APM has a little bit more settings. This APM setting is also with the real user monitoring. And again, SSL, this enabled false. And I did not find time to make better use of the username and password. I just hard-coded it here. I mean, it could have used the secret that we had before, possibly, but this works. And other things is basically allowing all origins, etc. And these are like some default settings from the APM setup for when you're enabling RUM. Again, SSL again disabled for the APM itself. Pod template. So again, like we do some sort of APM server, same story, 2 gigabytes, and then we refer 2 things: the Elasticsearch and the Kibana that we created before. Of course, this allows ECK to configure automatically the Kibana endpoint. So there's also like some other setup. And lastly, if you remember, we also had something called FileBeat that basically ships the logs. And same story, we use /Kibana for Kibana path, SSL enable false, and we say we don't really care about any SSL. So I tried to make it easy with no SSL, but of course you shouldn't you should look into having a secure setup in production. And over here it just basically says, okay, auto discover, like when you're running so FileBeat is going to run as a daemon set, so on each node, and that's basically kind of a thing that basically runs in the background, and it just works for you. And I believe it's 1 per node, so you don't need more than 1 FileBeat per node. It kind of pulls in everything that is needed. So this is setting the FileBeat, telling it to look for Kubernetes and automatically find out Kubernetes things like different kind of logs, etc. And then I also say, like, when you're processing, like sending logs to Kibana, maybe it's okay to ignore anything that has to do with the kube system itself. I'm not super interested right now, in this case, the Elastic system logs as well. And or when it's from the DevOps namespace as well, because that's where the Elastic Stack components are running. This is where the operator is running. And also, I don't really care about the ingress either. If I have issues, I try to look them up manually. I don't need to see them in my logs. So I will only have logs for my application. So that's also kind of easy. It makes it easier. So again, it's a daemon set, and you allows to provide richer host metadata. I don't remember exactly why this was for, but I guess the comment says it. So Filebeat run as user. I guess that's 0 is root. And these are the places where basically you can that you mount varlog containers, varlog pods, var lib docker containers. And these are the volumes that are mounted by Filebeat. Filebeat is an agent. It's kind of sort of an agent, so it needs to mount something that is on your node, and it basically pulls up everything. So these are the places where it would be pulling stuff from, like the different logs. And we'll see, like, later that the logs are in some sort of JSON format, so they get ingested easily by Elasticsearch. Okay, and then there are some roles. I'm not going to go in too much in depth in that, but basically Filebeat, where that is running in your DevOps environment, so it needs to be able to talk or like listen into things that are happening in your other namespaces. So that's what I believe this one is doing, and then you need to create some similar things. So multiple permissions. Okay, so from line 263 we start seeing more some interesting stuff. Like, one is ingress for Kibana, and basically it's just if you go to this path, it forwards everything to like this particular service. So let's actually see what services do we have actually in our get SVC. So we have like the APM dev, we have the ESDev, ESDev, HTTP, and transport. So these are like some services that are automatically created. But the most interesting thing is Kibana dev HTTP. And as you can see, this is port 5601. Let's continue with the ingresses. So we also create one more ingress, which is for the APM. This is, you'll see like later that this is for the real user monitoring to report its status so like a JavaScript application can report its status. All right, so that concludes the first part. And in the next part, what we're going to do is to run a simple multi-stack. Well, I call it multi-stack. Is like, using front-end Java and JavaScript Node.js with Postgres and Redis application. A simple application that I cooked up, like a stock application which just calculates stocks for characters from Futurama. So let's take it in the next video.